Hey there, in lesson 88 we're talking again about what is and what is not a proportional relationship. Has a lot to do with what we talked about with direct variation. We'll also use proportions or a constant factor, either one, to solve problems. Let's review three important things about what we call proportional relationships. 1. Proportional relationships involve two variables or two quantities that can change values, like distance traveled and the time spent traveling, or quantity of items and the total cost. As one variable increases, the other changes by a constant factor k. So our two variables are y and x. K needs to be a constant. So as long as we know that k has a value, then we have the two other unknowns, and it's a proportional relationship. In a table of values for the two variables, y and x, all pairs must form equal ratios. That is, in a proportional relationship, the ratio stays constant. This idea is expressed by the equation y divided by x will always be k. So they rearrange the direct variation equation from number 1. To remember what k stands for, or the constant of proportionality, think of spelling constant with a k, like it says there. And number 3, when you graph these, you graph the table of values, you'll find it always comes out as a line that goes through the origin. The graph may be a continuous line or may simply be aligned points. It's okay for the points not to be connected into a line. For it to go through the origin means that when y or x is 0, the other one has to stay 0. If you're adding 1 or 2 or subtracting 3 to the slope, then it's not going to go through the origin. It's not technically proportional. It's not a direct variation. So in example 1, they're asking which one is or are any and why. In letter A, it is not proportional, though it is linear. The taxi fare does not go through 0, probably because there's a base fee you pay before it starts following a constant factor per mile. Letter B looks like it is. It passes the two graph tests. It goes through the origin, because if you don't buy any pounds, you don't pay any dollars, so 0, 0. And it's linear, not connected, but that's still proportional. They don't change. Maybe when you buy 3 pounds, it's $6, but when you buy 6 pounds, it's suddenly $12, Actually, that was correct. If you buy 3 pounds and it's $6, you buy 6 pounds, it's not like $20, right? It stays proportional, whether it's by 2 or by 4. And area, you will find, actually will not be proportional either, at least not of a square, because it's a exponent there. S squared. So what ends up happening is you get a curved line. It's not linear, not proportional. It does go through the origin, though. In example 2, we see tables that record the effect of dilating or enlarging a square by its perimeter and then seeing what happens to its area, right? We've worked with scale factors like this before. Let's look at the tables and we decide which, if either or both, are proportional. How do we determine this? Just look at the table, pick a perimeter, divide it by the side length. Maybe this is x and this is y. We need to find that k is always constant, right? So divide y by x. Remember how we rearranged the direct variation equation? We want to do that one more time. Y divided by x. In both cases, the k constant is 4, and it's going to be all the way through here. Times 4, times 4. The constant is 4, so yes, it is proportional. In area's case, and I already sort of mentioned, area doesn't work, especially not with a square, because what's going to really happen is your x gets squared because the sides are the same length to get y, and that's not the same. That's not our constant equation. but we can check it. The constant of 4 divided by 2, right? That'd be 2. How about the constant of, let's try 25 divided by 5? Does it follow the pattern? No. So it is not proportional. We've done that before. The heights of similar triangles are proportional to their bases. As a triangle is enlarged, dilated, its base and height increase at a proportion. They give us the table, always makes it nice. Predict the height of the triangle shown when its base is 15. There are 2 ways we can do this. I bet you the one way you may like the best, because it's kind of like what we were just doing, is find out what the constant is by taking y and dividing it by the x on the left always. That's the input. That comes out to 1.5, 1.5. And they said it's proportional. We can double check. So if the k is 1.5, that means all we need to do is take the base of 15, and base is the x, so we multiply it by the k, the constant. And that would be height. 15 times 1.5 22.5. Now the other way that they show here first is you could set up proportions like 3/2 like this, and you could go, that should be the same as, well, does 15 go on the top or on the bottom? If I do 3/2, then 15 goes on the bottom, because we want our heights to be across from each other, and our bases to be across from each other. So we cross multiply. 15 times 3 is 45 equals 2 times h is 2h. Divide 45 by 2. H, I think, is 22.5. So 22.5 is our estimate, as long as it maintains its proportion, right? And it says it will if it stays similar. Couple more to talk through here. State whether each equation below indicates proportional relationship or if it's non-proportional, and justify. Remember what we said, the rules for these is you're going to have 2 variables and 1 known. In letter A, letter A here, I gotta change my color here. Okay, don't get confused. This is not a variable. We have the variable c. We don't know what it's worth. Probably the circumference is what it stands for. Equals, we know what this is worth. I'm going to write the number so it's obvious. 3.14 times diameter, right? 2 unknowns and a constant that will be the same. So this is, yes, good. Now in this case, we do have 2 variables. Area, we don't know. Input is radius. Again, we know pi is 314. So everything looks good until the squared. When you add a square, an exponent, the relationship will not come up proportional when you graph it. In letter C, we break the rule of the origin, okay? Because y equals 2x would be good. We have 2 variables, but it's not going to go through 0, 0 now. For example, if I put in x is 1, what will y be? Well, that doesn't help you. If I put in x is 0, y should be 0. But y will actually be 1, so it's not going to go through 0, 0. Okay? So just A is proportional. Example 5, which of these problems can be solved with proportional thinking? It takes 2 workers 5 hours. How long would it take 4 workers to complete the job? Letter B, the shipping charge is $2 per item plus a flat fee of $3, so it costs $13 to ship 5 items. What's the shipping charge? I'm going to say letter B. I notice right off the bat, I see a flat fee, which means, this formula is definitely going to have, I don't know, y and a k and an x, but there's definitely going to be, when you start with a base fee, like with the taxi cab or whatever it is, you add 3, and now it's not going to go through the origin because of that. No. In letter A, I don't think it works because we changed the number of workers. It's not going to necessarily stay proportional. If we kept just 2 workers, or maybe if we kept 5 hours, I think that would be it. I don't know. Maybe it'll explain it on the next one. Letter C is proportional because each student read the same number of students. 30 students read a combined total of 150 books. How many books were read by 60 students? Right? So you find out the constant is 5, which means 60 students would read 300. You can set it up that way, or you can do a proportion like this one. But with letter A, let's take a look at that one more time because I don't want to leave you out to dry on that. Two workers, 5 hours to complete the job. 5 hours is how long it takes. 2 workers is the amount that goes in times K. How long would it take 4 workers to complete the job? 5 divided by 2 is K. So I could put that in for K here. I don't know. You would think you could do that, but it's saying because it's not related by a constant factor. I'm thinking because in the case of the books, they read the same number of books. Each student is reading the same number, no matter how many amount we use. But this isn't going to be constant with the workers because how long the workers take to do a job is not constant when you switch to 4 workers. We can talk more about that in class, I suppose, but I do want you to do all the practice. And maybe D will be the one that challenges you. So we'll talk about that one in class.